Welcome to today's lesson. I'm Siamasaka Kianden. So I'm going to take you through actually a question which we are going to solve on actually hydroelectric power. So we go straight to the lesson. Okay, so as I indicated earlier on, we are going to look at electric power. Hydro means actually where we are using water. And so for hydroelectric power station, we have this arrangement for us to enable us to produce actual electricity. We need to have a reservoir. And the reservoir here is actually the lake, where there is water in this lake. And then this water is channeled through a pipe known as a penstock. And it should be at the base of the dam, actually, so that the pressure is increased, so it goes down until it reaches the turbine house, where there is a turbine, which actually is connected to the generator to produce electricity. And so here, the hydropower actually uses the principle of height. So the potential energy is as a result produced by the height. So we talk of this height from there up to there. And so this is the 0 point where it is actually, the height is starting from going upwards. So the higher the height, the more actually potential energy, and thereby more electricity to be generated. And so the first question is, let's state the formula for calculating potential energy. So potential energy is equal to mass multiplied by gravitational field strength multiplied by the height. M is actually the mass. And this mass should be in kilograms as the units. And G is the gravitational field strength. Which should be in newtons per kg. And H is actually the height. This height should be measured in actually meters. So we have done the first part of the question. The second question, state where the water has the greatest and least potential energy. So from our dam here, we notice that our reference point is actually where the water enters the turbine. And so we are going up. And so it means that the greatest potential energy would be at a point where actually the dam has the greatest height. So we're going to have the greatest potential energy where the water actually enters the penstock from the lake. And the least potential energy would be at the point where actually water enters the turbine house or emerges out of the turbine house. That is actually the least potential energy. And so now we go to the other question. In 20 minutes, the water loses this 9 billion joules of energy, and 6 billion joules of electrical energy is produced actually in the turbine. Calculate the efficiency of the conversion. So the efficiency of conversion is calculated by looking at the output energy divided by the input energy. And you note multiplied by 100 to take it to percentage. And you note that here, the 6 billion would be actually what is produced. And the input is the amount of water that is lost, which is 9 billion. Joules multiplied by 100. And this gives us actually 66.66 watts, which is approximately 66.7%. So this is the efficiency that is actually produced by this power plant. Okay. The second part of the question, calculate the electrical power output from the turbine. So the electrical power output would be equal to the energy which is produced in the turbine divided by actually the time. And you notice that here the energy was actually 6 billion joules divided by actually the time, which is actually 20 minutes. To take it into seconds, you multiply by 60. These are seconds. And so what you're going to have is actually 5 multiplied by 10 to the power 6 watts. So this is the power that is produced. And so state 2 advantages of hydroelectric power stations. Though electric power stations are advantageous, but they also have disadvantages. So number 4, the 2 disadvantages that the first one is state advantages. So the first advantage is that 1, there is no cost for water which is used. Cost for water is not there. Once the dam is made, so there is actually no cost involved, because the water is naturally coming from different aquifers or different places, and then it is reserved there. Also, hydropower has no pollution. No gases actually are produced. During the generation of power. And there is less heat produced as well, though they needed only 2, but we can include the third one. Less heat is produced during the production of electricity. Number 5, state 2 disadvantages of electric power stations. So these are actually advantages. So what are the disadvantages? Disadvantages of using hydroelectric power stations. Two disadvantages are that actually hydroelectric can cause flooding. Once the dam is full, it can cause flooding. And number two is that it destroys actually the scenery. The place actually is destroyed, okay? And it also minimizes land use. Because the land is buried, land use. And state one disadvantage of using fossil fuels. Actually, fossil fuels actually, they produce actually pollutants. They produce actually carbon dioxide. Which actually contributes to global warming. Okay, so state one disadvantage of using nuclear energy. Nuclear energy. Actually, it produces the waste, which is ionized waste, which is ionized, as well as the disposal is actually difficult. The disposal of nuclear waste is expensive. So this is the lesson for today. I thank you.